Alright, so we're going to talk about the limit comparison test. It says suppose that a sub n is greater than 0 and b sub n is greater than 0, and the limit as n goes to infinity of a sub n over b sub n equals L, where it equals some limit, where L is finite and positive. Then the two series, this summation a sub n and summation b sub n, either both converge or both diverge. So what might happen is we might have a series that's kind of messy, and what we want to do is we want to compare it to some other series that might not be so messy. And a lot of times you want to compare it to a p-series, and what you have to do is you have to choose one with an nth term of the same magnitude as the nth term of the given series. Okay? In other words, what you can do, you can disregard, when you're choosing a series for comparison, you can disregard all but the highest powers of n in the numerator and the denominator. Okay, so that's something you can do. Alright, so let's take a look at our first example. It says determine the convergence or divergence, and we have the summation n equals 1 to infinity, okay, of 1 over a n plus b, where a and b are both positive. Okay, so we know that this series here is positive. Okay, and that's what it says over here in this theorem, that a sub n and b sub n are both positive. Okay, all right, so what we'll compare this to is we're going to compare to summation n equals 1 to infinity. Now remember, it says we can keep the highest power in the numerator and highest power in the denominator. So in the numerator I'm going to keep the 1, and then in the denominator the highest power is the n to the first, so I'm going to keep the n. Alright, so what I need to do now is I need to see what this series does. Okay, if this series converges, then that means this series converges, as long as we satisfy, as long as we can take this limit here of a sub n over b sub n and it equals some number that's finite and positive. Okay, then the series that we're comparing it to, if it converges, then our series converges. And if the comparison series diverges, then our series diverges. But this has to be satisfied first. Excuse me. Alright, so let me see if this thing converges or diverges. Well, we know that this is going to diverge, because remember, for the convergence of a p-series, okay, so you can see here this is 1 over n raised to the p. And what is p in this case? Well, p is 1. Okay, p is understood to be a 1. And remember what the p-series says, that it converges if p is greater than 1 and diverges if p is greater than 0 but less than or equal to 1. And you can see that p is equal to 1, so that falls into this. So we know that this series diverges. Okay. Alright, so now what we have to do is we have to evaluate this limit here. The limit as n goes to infinity of a sub n over b sub n. Okay, So let's evaluate that limit. Alright, so this right here is going to be my, nope, I'm sorry. This is going to be my a sub n, and this is going to be my b sub n. Okay, alright, so I have the limit as n goes to infinity of a sub n, which is 1 over a n plus b, over b sub n, which is 1 over n. Alright, so now we have the limit as n goes to infinity, and this is going to be 1 over a n plus b, and then remember it's this divided by this, so that means it's this times the reciprocal of this, which is n over 1, which is equal to the limit as n goes to infinity. Whoop, I'm sorry, this should be n over 1. This is going to be n over a n plus b. Okay, now if you remember, whenever you're taking the limit of a rational expression as the variable goes to infinity, all you have to do is keep the largest term in the numerator, the term with the largest exponent in the numerator, and the term with the largest exponent in the denominator. So that's equal to the limit as n goes to infinity of n over a n. And then you can see here the n's cancel out, and so this is the limit as n goes to infinity of 1 over a. And anytime we take the limit of a constant term, it's going to be that constant term. So you can see that our limit is equal to some number 1 over a. Okay, this is finite because a is going to be some value. It can be a 2, a 3, a 4, okay, or whatever. And we know that this fraction here is positive. And how do we know that? Well, because it tells us in the problem that a is greater than 0. So that satisfies the conditions of the limit comparison test. So that means that the series is n equals 1 to infinity of 1 over a n plus b. Okay, since we got a positive finite number and the series we compared it to diverges, that means that this series here also diverges. Alright, and I hope this example's helped. I'll do a couple of more examples. I'll just show you the examples we're going to do. We're going to do this one. We're going to determine the convergence of this series using the limit comparison test, and we're going to, in the third video, will be determine the convergence or divergence of this series here. Okay, so hope you'll check those videos out, and if you like them, you can subscribe. All right, thanks.